All right, so last section we'll look at is 5.3. Okay, and we ended yesterday with the polar form of a complex number. Okay, just let's put that up. Does anybody remember what the polar form of a complex number is? How do you write it? Jamal? Yep. Exactly. So this format, if you write polar numbers, complex numbers in polar, basically gives you a quick way to do multiplication and division. And by quick, I mean you don't have to do any foiling, so you don't have any I-squareds that you have to change to a -1. You're not going to have like terms to combine. You're not going to have to split it into two fractions. You pretty much can do it in your head. But it does rely on your complex numbers being in polar. They cannot be written like this. That's rectangular. Right? We have to have the r and the theta, just like you did in the homework last night. Okay, so let's take a look at the formula. We'll do multiplication first. All right, so the problem I'm going to give you, the numbers are already going to be in polar. So you're not going to have to convert it to polar first. And in a real problem, I will give you a radius and I'll give you an angle. For the formula, I'm just saying you're going to have a complex number that'll have a certain radius and a certain angle. And then we'll have a second complex number, and it'll have a different radius. I just called it my second radius, and it'll have a different angle. I called it my second angle. Okay, so an actual problem will look, I'll just show you if I have one. That's what an actual problem will look like. Okay, it'll give you two numbers in polar. You'll know the radius, you'll know the angle, and we'll just multiply them together. Okay, so let's go back up and look at the formula for doing it. Okay, if you want to take the two complex numbers that are in polar and multiply them together, first thing you do is you take R1 and R2 and multiply them together. Okay, that's the first step. Take R1, R2, multiply those two numbers together. Okay, the second step is to take theta 1 and theta 2 and add them together. And that's it. That's how you multiply two complex numbers in polar. Just take the two radii, multiply them, write that number down. Take the two angles, add them, and write that number down. And that takes the place of all the work we had to do. All the foiling and changing to I-squareds, combined like terms, all that stuff is going to go away. But you have to have your numbers in polar. That's the way this works. Bless you. All right, so I have two complex numbers here. I called them Z and W. You can call them anything you want. It doesn't really matter what you call them. We're just going to multiply them together. All right, so if I want to multiply Z and W together, what is the radius going to be in my final answer? Gabe? 15. Yeah. And that's half the problem. We've got the radius. Okay, the last thing we have to do is find the angle. So we look at the formula, and if we use the formula, what will the angle be in the final answer? Jamal? No, not 2,000. Mercedes? 120. So you multiply the numbers in front, but you add the two angles. So 220 plus 100 is 120. And that's it. That's the whole problem. That's multiplying complex numbers, just like we did yesterday, but it's a lot easier in polar. Okay. Any questions on that? Okay, let's try, I think I have another one. Okay. Take a second and try that one on your own. See if you can find z times w. And those are your two numbers you're working with. All right, so first thing we're going to do is find our radius. So Devin, when you do z times w, what do you get for the radius?
5.
Yeah, you take 1/2 times 10, we get 5. Sometimes what I do is just finish setting up the whole thing and just leave a couple spots where you're going to fill in your angle. How about Wendy? What's my angle here?
I got 345.
Okay, so there's a few different ways you can write the angle. Did anybody else get 345? Okay, what's another angle that people got? And it's probably going to end up being the same thing. Yeah? Yeah, you can do -15. Usually I just put it in parentheses so we know that it's not minus, it's a -15. Okay, so that's how you could do it as a negative angle. Wendy, what did you add to that to make it positive?
I did it on top and I 15 and 30. Because I did it on.
Oh, you made this
Yeah.
positive right away.
Yeah.
Okay, so to make that 330, what did you add to it? Yeah, you add 360. So if you do that in the final answer, you get 345. Any questions on how those two angles are the same? It's just one's clockwise, one's counterclockwise. Okay, so that's a second way you could write the answer. Okay, and I'm going to show you a third way that I haven't, we haven't really spent a lot of time looking at it, but it's actually even simpler than adding 360. It's easier to do in your head than that. So nothing's going to happen with the 5. That you can't really change. But I want to look at what the cosine of -15 is. And I need to go to degrees. Okay, here's the cosine of -15. Okay, it's that number. Here's the cosine of +15. How do those two answers compare? They're equal. So there's no difference between cosine -15 and cosine +15. So what does that mean I could do with the negative right here? Just get rid of it. I don't need it. Okay, when you have a negative with cosine, it doesn't make a difference. So if you wanted, just get rid of it. Cosine of -15, cosine of +15, same thing. Let's try it with sine and see what happens. Sine of -15, that's what you get. Okay. Sine of +15. What's the relationship between those two answers? Yeah?
They're the same numbers, but one is negative and one's positive.
Yeah, one of them just has a negative in front, that's all. So with sine, you can't get rid of the negative, but what you can do is put it in front. So if you have a negative angle, just put a negative in front of your answer. So what I'm going to do is move this negative in front. So instead of being a plus, it turns into a minus. All three of these answers are correct. Okay. If you get an answer like this on the test right away, you don't have to do any work at all. If the angle is already positive, then the answer is going to be listed on the test as a positive. But if you get a negative angle, I might do two things. I might either write it like the second way, or I could add 360 the way Wendy did and write it the last way. Okay. But the last one, if you get that right away, you don't have to worry about anything else. That's the best one to get. Okay, so any questions? What happens if you have a negative angle? The two ways you could fix it if you have to. All right, if that comes up again, we'll try it. We'll fix it both ways. Okay, so any questions on multiplying? Those two. All right, so let's take a look at this. I want to just FOIL this the way we did yesterday. And then what I'm going to do is write it in polar. And I'm going to do it that way. And I want to see, do I really get the same answer? Okay, so what I'm kind of doing here is checking, does that formula that I just gave you really work? And we'll see how much faster it really is. All right, so Dave, if I was going to do this out, can you tell me all the steps I got to do?
FOIL
2 to negative 1, okay?
and then 2 to negative I,
2 to negative I, yep.
and 2I with negative 1,
2I to negative 1, so it's another negative 2I.
and then 2I with negative I.
And 2I to negative I gives me negative 2I squared. Now, I got to combine my terms. So negative 2. What's negative 2I minus 2I? Becky?
Negative 4i.
Yep, negative 4I. And this is a negative 2, but we have to now change the I squared to negative 1. And now I can do that out. So I get negative 2 times negative 1 is positive 2. So actually in this one, the real part cancels out. I get, if you want to write it, you can put 0 minus 4i. Okay. So any questions on that? Now I'm going to do it in polar. And it's going to take me a couple seconds just to change these two numbers into polar. But once I do that, it's going to be a lot faster than what we just did. And this one wasn't even that bad because the numbers worked out kind of nice. So 2 plus 2i. Okay. Right 2, up 2. What would be the angle if you go right and up exactly the same amount? It's kind of easy when these two numbers are the same. Gabe?
45.
Yeah, the angle here is a 45. If you didn't know that, you could use inverse tangent y over x and find it. And you'll get 45. Okay, so that angle here is 45. And how do you find the radius for this point? If this side is 2 and that side is 2. Yep. Okay. Yeah, go ahead, Jack. Yeah, it's the Pythagorean theorem. So just do x squared plus y squared equals r squared. And just to do it quickly, I'm not going to reduce it. I'm just going to leave it as square root of 8. So this number in polar is r cosine theta plus I sine theta. That's my first one. And now I'll put my second one right below it. Let's do that one right here. Okay. Negative 1 is the real part. What's the imaginary part? They didn't put the number this time.
Negative 1.
It's also negative 1. The reason I picked two numbers that were the same, like 2 and 2 and negative 1 and negative 1, is it makes the angle faster to find. And I didn't want to spend a lot of time trying to find the angle. Okay, so negative 1, negative 1. So that angle is a 45-degree angle in the third quadrant. So what would be the angle to go the way I just traced? If If you're stuck, think of it, you got to go halfway, right? Figure out what halfway is, and then you're going 45 degrees past halfway. Yep. Yep, it's 225. And radius, if you use the Pythagorean theorem, each side of the triangle is 1 unit. So what's my radius? Square root of 2. Okay, so my second complex number, writing it in polar, is r cosine theta plus I sine theta. And now, let's multiply them this way. We already know what we should get. The answer is negative 4i. But let's do it in polar the way I just showed you. And I'm going to prove you get the same answer. Okay. Let's start with square root of 8 times the square root of 2. What's the square root of 8 times the square root of 2? The square root of 16. Yep. So the product is square root of 16. And what do I do with my two angles? Janelle? Add them up and get 270. That's the answer. Now, does that answer look like that answer right now? No. It doesn't look exactly the same, but if you simplify a couple things here, it is. Let's start with the square root of 16. What's that? 4. Okay, so we get that. And now on our calculator, let's take the cosine of 270. Let's see what it comes out to. So cosine of 270, 0. Okay, that's gone. Just like the real part was gone up above. We got 0. Okay, so we got 0 plus I times, now let's do the sine of 270. I'll do it on here. I get negative 1. Okay, so what's I times negative 1? Negative I. And then plus 0, but adding 0 doesn't change it. And then what's 4 times negative I? James? Negative 4i. Is that the same answer that we got up above? Yeah. So I'm just showing you that if you change these to polar and do it the new way, you get exactly the same answer as you would doing it the old way. Okay? It's the same thing. If your points are already in polar, this way is a lot faster. This time I don't think it was faster because you had to convert that to polar and then convert that to polar. The problem on the test, it's already going to be converted for you. So you're not going to have to do that in this problem. Okay. But that's also a good review because I'm going to have a separate problem on the test where you do have to convert a point to polar, but that's it. That's all you have to do with it. Okay. So any questions on how we converted a point to polar or how to multiply in polar? So it's actually reviewing two separate things on the test. All right, so let's look at division. So if you want to write this again, you can, or you can just kind of have an arrow using the same two numbers you had up above. I've got two complex numbers, and this time I'm going to divide them. So if you know how to do multiplication, then you probably can figure out how to do division. It's almost the same thing. It follows a nice pattern like the last one. When we multiplied, what did we do with R1 and R2 last time? Yep, we multiplied them. What do you think we're going to do with R1 and R2 this time? Got it?
Divide them.
We're going to divide them. So in your final answer, the radius is R1 divided by R2. Last time, what did we do with the two angles? We added them. What do you think we're going to do with them this time? We're going to subtract them. So in terms of the level of work, it's exactly the same amount of steps, except this time, divide your 2 radii and subtract your 2 angles. And that's it. So this is going to take the place of everything we learned when we did division with complex numbers. You don't have to find the conjugate. You don't have to FOIL. You don't have the I-squareds. You don't have any of that. So if you've got numbers in polar, this method is a lot faster. If your numbers are not in polar, it might take longer to change them to polar. So you might want to use the way I taught you yesterday. Okay, so here's our 2 numbers. Okay, Z is 3 cosine 75, I sine 75. And W is 5 cosine 30, I sine 30. Okay, does everybody have what's in the box so I can scroll up? Yep, okay. Okay, and I want to divide them. All right, so Sydney, to find the radius in the final answer, what am I going to do with the 3 and the 5? Yeah, we're going to divide them. That's it. That's my radius, 3/5. Last step is to find the angle. Okay, so to find my angle, Brianna, what am I going to do with the 75 and the 30?
Subtract.
You're going to subtract and do it in exactly that order. 75 minus 30 would give me 45. And that's it. That's the answer. Okay, this one I'm not going to prove to you. Like I'm not going to do this one the old way, like we did yesterday, and the new way. I'm just going to do it the new way. You could check it the old way, and it would work. But it would take a while to do that. So, hey, any questions on that one? All right, so try example 4. Okay, you get 10 cosine 20, I sine 20, and W is 1/2 cosine 100 plus I sine 100. All right, first thing we're going to do, find our radius. And what's the radius going to be here? Gabe? 20, yes. Sometimes people put 5. Okay, if this wasn't a 1/2, if it was a 2, it would be 5. But if you take 10 and divide by 1/2, you get 20. Okay, so that's good. And Gabe, what did you get for your angle?
280.
Okay, did you do it as a negative first?
Yeah, so 20 minus 100 is negative 80.
Negative 80.
Yeah, 360.
Okay, so that's one answer that is correct. And Gabe, what did you just say to make it positive?
Yeah,
Add
360.
360. So another answer that would be correct is, what do you get when you add 360?
280.
280, yep. And the third way, I'm not going to write it down. Let's just go over it. What's the third way? What can you do? Explain what you do with the negative on, there's 2 of them. What do you do with each one of them? Mercedes?
Change the cosine to cosine 80 and then
Yep.
minus I sine.
Right. With cosine, you just get rid of the negative. With sine, you could just move it in front. And that would be a third answer. That is correct. Right. So any questions on that? Okay, so it's multiply, divide, and this one. Let's see. How would you write that out? What does that mean to do? 2 plus 3i cubed. It means, like, if you had to explain it without an exponent. Graham, how would you write that down?
You just write down 2 plus 3i, 2 plus 3i, 2 plus 3i.
Yeah, you just write the same thing 3 times. Okay, and this one's not too bad. I mean, if it starts to get like up around an exponent of 7 or 8 or higher, then it gets really bad to do it this way. But let's do this and just see what we get. So we get 2 times 2. And for now, I'm forgetting about everything that's after that line. I'm just doing the first 2. I'll do the last one after. I get 2 times 3i, another 2 times 3i, and then a 3i times 3i. What number is that? 9i squared, which is negative 9. And then if I combine like terms, 4 minus 9 is negative 5, plus 12i. Okay, that's what you get when you multiply the first 2 together. Okay, and then we still had one more, and now we have to do it again. Okay. 12, 6 plus 6. Okay, so we did the first 2. Now, because it was cubed, there's one more. We have to do the whole thing again. So negative 5 times 2 is negative 10. Negative 5 times 3 is negative 15. 2 times 12 is 24. And what's 12i times 3i? 36i squared, which is negative 36. What's 24 minus 15? 9. So 9i, and Jamel just said this was negative 36. So my final answer, if I take 2 plus 3i and cube it, what's negative 10 minus 36? Negative 46. That's the answer. So I'm showing you this because I wanted to show you how much is involved to cube something. It's not bad. I mean, it didn't take more than like 2 minutes. But now if you wanted to take 2 plus 3i and do something like that, you have to write 2 plus 3i 12 times, and it's going to take, I mean, it's probably going to take like 20 minutes. So there's got to be a better way than doing it out this way. Okay, and there is. As long as you know how to write this number, how do you think? In a different way. What would be the different way? Polar. If you know how to write this number in polar, you can raise it to any power. 12 thousandths, 12 millionth power. It wouldn't make a difference. I could do each one in the same amount of time. Okay? And the trick, it's called de Moivre's theorem. Okay, and it's just like the last 2 formulas. It's a very simple calculation. But it depends on your number being in polar. You cannot write it like this. It has to be in polar. Okay, and the trick is you take your radius and you raise it to the power. So you just type that in on the calculator. Whatever your radius is, raise it to the power. Take your angle and multiply it by the power. So I think the trickiest thing with all the formulas today is to just not mix up which one is which. When do you add angles? When do you subtract angles? When do you multiply the angle? Okay, so raise the radius to your power, multiply the angle by your power. Okay, so the next one we're going to do is an 8th power. It's definitely one you would not want to try by hand. Okay, it would be a lot worse than this. Cubed, I think you can reasonably do by hand. 8th, not really. Okay, you'll probably make a mistake somewhere with arithmetic, and if you make a mistake in one step, it messes the whole thing up. So here's the number that I want to raise to the 8th power. It's 3 cosine 20 I sine 20. Okay. So to find my radius, what would be the calculation I have to do? Three to the eighth power. If that number starts to come out too big, I'm just going to leave it as 3 to the 8th. I'm not even going to do it out. But let's just see. That's not too big. So 6,561. If it starts to get in like the millions or billions, a really, really big radius, don't write it out. Just leave it. Okay, but 3 to the 8th is 6,561. Okay, and I'll just put below that how we got it. It's 3 to the 8th. Cosine. And what's going to be the calculation for my angle? 20 times 8, which is how much? 160. And that's it. That's how you can raise something to the 8th power very quickly without having to do 8 sets of FOIL, which would take a very long time. Okay, so what I'll do on the test tomorrow is out of the 3 formulas that we just learned, I'll probably pick 2 of them and put them on the test. Okay, and they'll be the last 2 questions. Okay, so any questions on multiplying in polar, dividing in polar, or raising to a power in polar?
Let's see, 160.
The 160, let me write down, we got 8 times 20. Take your angle, multiply by the power. 8 times 20. Okay, any other questions on raising to a power in polar?
Like the regular one with the homework last night, how did we get the, what was
Like the radius?
the
of-
equation for the, theta?
For theta? So there's 2, I'll go over that in 1 second. I'll mention what that is. So let me write down a list of things that are on the test, which is going to include what Jackie just asked about. Okay, so things you want to make sure you know how to do is graph in polar. That's where I give you a grid with a bunch of circles on it. I give you a coordinate like 4, 90 degrees, and you have to graph the point. So you want to know how to graph in polar. Convert polar to rectangular. Polar to rectangular. Okay, that's where, I'll put the formulas that you use there. To convert polar to rectangular, that's where you use these 2 formulas. That's your r cosine theta, r sine theta. Okay, the next thing is converting the other way, and that's what Jackie just asked about. Convert rectangular to polar. Okay, for that, to find the radius, you use x squared plus y squared equals r squared. And then to find the angle, which trig function do we use? Yep. Close. Not tangent, but inverse tangent. Inverse tangent, y over x. And that'll work as long as you're in what quadrants?
1 and 4.
Quadrant 1, quadrant 4. If you're in quadrants 2 or 3, what do you have to do to adjust that a little bit? You have to add 180 if you're in degrees. What if you were in radians? Instead of 180, you would use pi. Okay, so that's how you find theta. Those formulas are exactly the same formulas you use whether you're doing imaginaries, like last night, or what we did back on Monday and Tuesday. You use the same formulas. All right. Okay, the next thing is know how to add, subtract, multiply, and divide complex numbers. And for this one, you can do it the old way, so in rectangular. So that's when you have a number written like 2 plus 3i. That's not the r cosine theta. That's polar. Okay, so adding and subtracting we did on, I think, Wednesday? No, Tuesday? And then multiplying and dividing, we did those yesterday. All right. So next thing is, we also did this yesterday, convert a complex number to polar. So convert complex number to polar. And that uses the exact same formulas that you did for number 3. Okay. What's the format of a complex number in polar? Somebody just give me those letters. Yep. I sine theta. That's doing this. All right. Sixth thing is graphing a complex number in the complex plane. So graph in complex plane. Which axis is the real axis? Which way does that one go?
Horizontal.
That's horizontal. And the imaginary would obviously be vertical. Okay, so you're going to have a couple problems where you have to just do a graph. And the last thing is what we just did today. Multiply, divide, and raise to a power in polar. So multiply, divide, raise to power in polar. And that's only for complex numbers. The stuff we learned today, it's only for complex numbers. Okay, so that's the 7 things that are on the test. Some problems you'll have 2. Like I might give you 2 convert to complex numbers to polar, couple graphs. So the test is probably around, I think it's 14 or so questions. Okay. Does anybody have any questions on graph in polar? Oh, the first thing?
Yeah, graphing in polar and complex.
So graphing in polar is, make this bigger. When you have something like that, and they'll give you a radius and an angle. Now there's 4 different ways they can give you a point. They could give you 2 positives, 2 negatives, positive, negative, negative, positive. How do we graph that point? I start by going 2 units. Which way? 2 to the right. So I'm just going to put a temporary spot. I'm going to erase that in a second. And now 135 degrees, is it clockwise or counterclockwise? Counterclockwise. So we go right 2, counterclockwise, and that's it. Okay, so for the first topic on the test, that's what I'm looking for.
And it'll have a graph like that.
It'll have the graph already drawn on the test. Yep. What if the radius was negative? Which way would you start moving? You wouldn't go to the right. You go to the left, and then you start from there. Okay. So let's just try one of those. Okay, so if I did negative 2, 135, I would start by going 2 to the left, and then 135 would bring me right there. Okay. If I go a quarter of the way, that's 90. And then each line on my grid is 15. So 15, 15, and 15 gives me 45 degrees past 90, which is 135.
Are you going to get a graph like that, or are we just waiting?
What's that?
Are you going to get a graph like that, or?
Yeah, I just mentioned that. It's already grid. There's a grid on the test. Yep. Okay, so that's graphing in polar. Was there something else somebody mentioned they wanted to take a quick look.
Graphing
Graphing. Okay, so yeah, number 6. So it would say something like graph 2 minus 4i. Okay, how would you graph that starting at the origin? What direction do I go first? Yep. Over which way? To the right 2. So right 2, okay? And then down 4. That's it. That's how you graph a complex number in the complex plane. Okay, just don't mix up the real and imaginary
What if I
axes.
do,
This kind of problem won't have a square root. Number 6, nope. It'll be nice numbers. Okay, any other topics? This we practiced a lot last night, number 3. Number 2, we haven't done that one in a while. Okay, that was something we really only did on Monday. We didn't do it the rest of the week. Okay. Anything else? Yeah.
Can we convert complex numbers to polar?
Convert a complex. Yep, that was last night's homework. So let's just take and convert that to polar. 2 minus 4i. Okay. To convert to polar, you have to find your angle. But what's the first thing you should do when you're trying to figure out your angle? Gabe? Yep, exactly. You got to figure out the quadrant because you have different formulas, which I wrote on the board depending on the quadrant. So we're right 2 down 4. That's quadrant 4. Gabe, do you remember the formula for theta?
Yeah, inverse tangent y.
Yeah. Do you add 180 here? No, not in quadrant 4. So y over x. So when I type that in, I could just type in the inverse tangent of what number? -2. So my angle,
That was regular tangent.
yes, thank you. So my angle is -63.4. Okay, and to find my radius, that's where you use the formula that looks like the Pythagorean theorem. R squared, x squared, plus y squared. Okay, what's x squared plus y squared going to give me? 20. So if we take the square root of 20, what does that reduce to? 2 square roots of 5. Yep. So we have our radius, we have our angle, so now we just have to fill into the r cosine theta. That's r. Cosine -63.4. Plus I sine -63.4. Okay, any questions on the 3 ways you could fix this? Or 2 ways to make it a positive angle?
I know there's plus 360, but what's the other?
Yep, so you could plus 360 to that number, and that would give it to you. Or what's the other way? Yep,
Cancel your negative for your cosine.
just get rid of the negative for the cosine
And then you subtract it to the add sign.
and move the negative in front for the sign. Either way is correct. If it's a multiple choice, you just have to look which way I did it. Does anyone want me to write that out?
Yeah.
So one way to get your answer is just take the negative away from the cosine. It doesn't make a difference. And move the negative in front for the sine. Those are the same answer. And the third way would be to take -63.4 and add what number? Add 360. And And that's how you write a complex number in polar.
Do you always take the negative away from both sides?
If you're going to take it away from one, yeah, you should do it everywhere. Yeah. Like don't leave this as negative 63 degrees and then just add 360 to this other angle. If you're going to get rid of it, we'll get rid of it everywhere. Yep. Okay, so that was this. Okay. Any other questions? Okay, just be careful on number 4 when you add and subtract. Would you do FOIL for something like this? No, you don't FOIL that because there's a minus sign. Okay. What would you get if you do that out? What would be your real part?
-2.
Yep, -2. And what about your imaginary part? 11i. Question why it's 11. Remember, that negative applies to both. So once you distribute it to the -8, it becomes like a +8 with a +3. Okay, so any other questions on that? Okay, so the homework tonight is just a couple questions. So it's 33, 35, 37, 41, and 42. On 41 and 42, they ask you to do something different. I'm telling you, you can just leave the answer in polar. Okay, so you still have about 15, a little over 15 minutes. So I'll get a couple extra books. I think you could probably finish that homework in 5 minutes. So if you finish it, just show it to me, and I'll check it off, and then there's no homework other than just to study for the test.